Okay, so here we have two shapes here, and these came from we had y equals the square root of x minus 1 from 0, or from 1 to 5, but in this case it was rotated around the y-axis.
Okay.
Okay, and so this shape here was what you got when you rotated which area?
When you rotated this area here.
So you got something that had a hole in it. And this area was, this volume, interesting shape, was what area rotated around?
It's when it's rotated this area here.
Yeah. And actually you can tell by the shapes, these shapes, which are sort of the correct scale, shows that we haven't run this to the correct scale because this is the square root of x minus 1, so at 5 this height would be 2, but it's almost the same length as the 5. So how do we calculate these volumes? There's kind of an interesting one. Let's do this one first.
All right.
We'll just set up the integral. We don't have to evaluate it.
So here, for your cross sections, instead of circles, you have rings, and you have 2 different radii, and this is the area you want to find.
Okay.
So.
All right. So what's the outer ring length? Radius length, I mean.
So the big radius is always 5 here. So we have the integral from one. Actually, no, we're going around the y-axis, so
Okay.
I'm going to wait on that. But we have pi times the integral from somewhere to somewhere of 5 squared minus this integral we have to express in terms of y's and dy's because we're going around the y-axis.
Okay.
So
it was y equals x minus 1. Y equals square root of x minus 1.
like that, or is it?
Yeah, just like that.
All right. So we have so we go over x and we go up. Alright, so I want to write this turns into x equals y squared plus 1.
Okay.
So, and x is our inner radius here.
Alright.
So we have 5 squared minus y squared plus 1 quantity squared, and then the dy.
Okay, and now what are the limits of the integral?
This is the y limit, so it goes from 0 up to 2.
Very good.
0 to 2.
Right. And whatever that is. And we'll leave this shape for a different time, but you can see that they very nicely fit together into a cylinder, which is what you would expect.
Because we're rotating the rectangle on the y-axis.
Yeah, but there's one other thing I wanted to... We also talked about shells. So do you remember how to do this integral, set up this integral in terms of shells?
The cylindrical shells.
Yeah.
So we have a base radius, a height, and the dy. So we have, take the pi outside again. Pi times the integral. I think we can use y's again. Actually, it shouldn't matter, but
Well, the shells use x's.
okay.
So think about what the shells mean.
Shells are, so we have the radius of the shells going out is x times the height of the shells, which is the y value, square root of x minus 1. Because pi r squared height times the thickness, dy. And then x is going from 1 to 5 here.
Yeah, this is not right at all. Start again. Start again. What are the shells? Draw the shell in.
So when we rotate, we're going to have another part over here. So the shells like that.
And those are just small shells. So what is the volume of that small shell?
So it's the area of the base. Or is it? Yeah, area of the base times the height times the thickness.
That would be the volume of the cylinder, but we want the volume of the shell.
So base times height times. So we need to somehow work the thickness in there.
Okay, the shell has some tiny thickness.
Which is the dx.
dx, yeah. So what is the volume of that little cylindrical shell? Remember, it's hollow.
Yes.
Completely hollow shell. So I have a shape that has some shells here, but I don't know how well it shows up. What do you got?
So, well, I would write this as you'd have pi times r squared height times pi times r minus dx squared times the same height.
Okay, yeah, that is basically the right concept. So it goes around and has a height. So how far around is it?
The circumference is 2 pi r.
From 1, 5, 2 pi x.
The x is the radius.
X is the radius. How high is it?
It is square root of x minus 1.
And how thick is it?
Dx thick.
Dx. So it's just the circumference times the height times the thickness. So the volume comes from the circumference. So the surprising thing is this integral, 1 to 5, 2 pi x times the square root of x minus 1 dx. And this integral, pi times 0 to 2, 5 squared minus y squared minus 1 squared dy, are describing the same shape and therefore have the same answer. Okay?
Alright.
All right, we'll check that off camera.